I'm John.
I'm David.
And we're here from Intelligent Concrete answering all your concrete questions. Do you know what our question is today, David?
No idea whatsoever.
What is the weight of the Earth?
The weight of the Earth.
That's
It's less than the sun, more than the moon.
more than a moon.
Right.
No, we're going to be talking about things dealing with concrete bridges. David, did you know there's a little bit over 600,000 concrete bridges in our national inventory?
I had a pretty good idea of that, yes.
It's pretty awesome. It's pretty awesome.
A lot of bridges.
A lot of bridges, and there's a lot of civil infrastructure that goes into getting us to our bridges and getting us away from our bridges. Is that a fair assessment?
Sure, we've got highways, we've got pavement, we've got all kinds of stuff.
Now, why do you think we care, and why do you think we're talking about bridges?
Well, if we didn't have bridges, we couldn't get anywhere.
And, true or false, bridges are expensive to put in? True or false?
True.
And they're expensive to replace.
True.
So what we want to do is put bridges in place that can last decades, even close to hundreds of years,
That'd be nice.
without having to do any type of rip and replace we call R&R. And as little maintenance as possible. And it all starts out a good concrete mix. Is that a fair assessment?
Absolutely.
Now, one of the things that I do a lot of bridge work, one of the things that I always notice about bridges, we never put a bridge over a beautiful, lush pasture that is constantly in 70 to 72 degree Fahrenheit, rarely sees rain. Normally, we're putting our bridges over big bodies of water.
Sure.
Brackish water, salt water.
Right.
They could be bridges in wastewater treatment plants. But normally it has to deal with water and something else.
Yeah.
Something in the water. And what is the worst possible thing we could do with our concrete?
The worst possible thing we could do with our concrete.
So
we could let it erode or deteriorate.
Around water specifically.
Right.
Especially concrete that has reinforcing steel in it.
Right.
And what is it? The Portland Cement Association says that the leading cause for premature concrete failure is deterioration due to damaged reinforcing steel.
Sure.
Which is normally in bridges over water with other stuff in it.
Of course.
So our first question today is, what is colloidal silica and how do we use it for concrete bridges?
Well, for the concrete mix, it's not too much different than any mix. We use it to make it less permeable. We use it make it more resistant to chemical attack.
Totally.
Is bridges the only place we want that? No, we want that most places.
You're totally right. And one of the problems that we have with colloidal silica is that oftentimes whenever we talk about where it can be used and how it can be used, you can use it almost anywhere we have a cementitious composite for a lot of performance enhancements or features and benefits. When it comes to bridges, like David said, it's just like anything else, whether you're going after pavements, bridges, locks, levees, dams, spillways, where we want a reduction in percolation, reduction in permeability, increase in densification, a more cementitious bang for our buck.
Yeah, going back to your original point, maybe we're willing to spend a little more on bridges just because they are more expensive.
Right.
They're harder to redo. So, maybe driveway, bridge, no offense to the residents, but...
None whatsoever. None is meant. None is meant.
But maybe we're willing to be more careful, spend a little more.
If you want to take some offense, go right ahead, but...
it wasn't me that said it.
Right. No, that's the point, though. And to look at it by using colloidal silica, so we have three types of bridges, right? The way I see it. And
Okay.
I think you can split it up to even more, but you have the bridge that was just put in place.
Right.
The bridge that it's been used, but it's not abused yet. And then you have the bridge that, maybe it's time to tear it out.
Maybe.
And then there's an infinite amount of possibilities in between those.
True.
Right? So when it comes to how to use colloidal silica for the brand new bridge that's about to be put in place, the way I see using colloidal silica is mixing it directly into the mix.
Oh, without a doubt. We want it in the concrete mix, and once again, we want the best surface we can get.
I knew you were going to go there. Knew it. So what would you use for that, David?
Well, I'd use it both places. I'd use the colloidal in the mix itself to make the structural part
Sure.
of it the best that we can. And the term that you hate, that I use a lot, I'd make the hard shell candy surface.
I don't hate, that's not the one I hate. The one I hate, because I use that in my PhD when I'm talking about the hydrated cement matrix, right? I don't like finishing aid.
Oh, John. Oh.
I see.
You know, oh, John.
I don't like finishing aid because you piss off a lot of people.
Yeah, you know, you've heard me say this, and I've said this to groups when I've been giving talks. Anything that's a liquid is a finishing aid. Coca-Cola, water, whiskey, perfume, you know, but
Don't use those! He meant to say that!
don't use those. I mean,
A topical admixture, a topical additive, I think is the best way, in my opinion, the best. It's so much more technical, it doesn't roll off the tongue, but it's very important to say that because I agree that top surface, that is the first line of defense.
right?
Maybe that's better than the hard candy shell, but it's still of the same nature. We create that to create a concrete, that sacrificial layer that is stronger, lasts longer, so we increase the life of our total concrete.
That's right. I think it's important to use words and terms that are precise and they say what they are, say what they mean. So topical admixture, I mean, it's just that.
Right.
It's topical
And you're mixing
it into the surface, as you should with colloidal silica, but as you shouldn't with just ordinary liquids.
So that being said, the other two pieces, we go from topical admixture to a topical additive, where, you know, our bridge is being used but it's not abused yet. It's to the point where maybe it's time to replace it. That's when we should use the topical additive, because we can't mix anything in with the concrete. But the concrete has gone through deterioration. It has cracks, it has pores, it has permeability. It also has nasty materials. Now we can use colloidal silica modified technologies or base technologies to spray on top of our deteriorated concrete to almost, I don't want to say bring it back to life, but at least rehabilitate it.
That's right. Well, there's the early days as we start to see that surface abrasion.
Right.
You know, we can treat that, get after that. I mean, it's just, I use this many times about painting. I mean, if we start to see rust in the paint, we get after it. We take care of it. We don't want it to just rust right through.
Right,
So,
which I did on my Santa Fe.
Oh,
I did. I let
yeah.
it totally took away the door. Oh.
Yeah. So we've got the early stages where we can use a thin coat, we can use a spray, we can use something. But then as we get farther on, as you described, so we've got sealing, and then later on we've got healing.
And that's the thing. By the way, if I had to say it, when you go to those points where you've got some deterioration, there's going to be a cleaning process.
Oh, yeah.
And I don't think, now we're just talking about the types of colloidal silica technology, and I think for both of those, you have different types, for both of those scenarios, I should say, you have different types of colloidal silica to create that sealing effect,
Right.
and then the healing effect, and you're being a little bit more aggressive when you're going after that healing effect.
Sure. That's right. Makes perfect sense.
When I go to Australia to speak, you know, they have this really cool speed dating thing. It's not speed dating. It's the only way I can describe it, though. Where you're standing in line, it's like you're on a speed date.
Do I need to get witness?
No, you don't need. No, I don't need to get in trouble. They have two lines of people, right? So in both these two lines, they're facing each other. This line moves. This line doesn't. When I say it moves, after about 2 minutes, you have to scooch down a person, right?
Yeah.
And you introduce yourself to the person in front of you and ask them different parts. Basically, it's a sales technique. How do you create interest and, you know, blah, 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 for revenue or for, you know, commerce back and forth. And then I would ask everybody, when I give this presentation, I ask everybody the same question. How much were you short on your, what's it called, rehabilitation or repair funding for last year? And they all go, ha!
Way short.
25%, 50%.
Sure.
And then I asked, so, okay, how much money do you have for new construction? And if they didn't laugh the first time, the second question, they're like, you know, money for new construction, there's always new projects.
Yeah.
But I'm talking about tearing out old structures that, you know, they say we have 312 dammed facilities in the western U.S. or in Colorado, wherever it is. And David's the dam guy here. But
That's DAM guy.
that's the AM guy. But not all 312 of those are the Hoover Dam,
True.
right? Some of them are small, local, and do we really have the money to replace that infrastructure that, I mean, we rely on for our day-to-day activities? And
Probably not. I mean, it's probably a topic for another day, but
Totally is.
that's where risk analysis came up,
Right.
How much can you afford not to spend? How much can you afford to spend? And put it on a risk basis.
And then when it comes to colloidal silica, some of these technologies, they're not as expensive as replacing the entire structure, obviously, or just doing patchwork.
Absolutely. I mean, it's a pretty small investment for a pretty large return.
Right.
And, we don't talk dollars because we don't sell products, but still, it's a relatively small investment.
There are enough companies out there, if you type in colloidal silica plus marine structures,
Right.
you're going to find enough information about structures that were rehabilitated back in the late 90s that are still in use today.
Right?
I mean, you want proof in the pudding? I
Sure.
think there it is. So hopefully that answered that question
Yeah.
on, for bridges, what is colloidal silica and how to use it. If you have any more questions, any more concrete concerns, please let us know. Don't forget to like and subscribe.
Ring that bell.
Go concrete!
Beat asphalt.